Page 125. Okay, we haven't done any wavefront question, so maybe this question is good to jog your memory. So if the wave is traveling through a water tank with the same depth, they will have equal gaps, equal size gaps between them. And this size of the gap is called wavelength. Still remember? So they should have equal wavelength. Okay? And then for this kind of question, I will need you all to count the gaps, not the wavefronts. Count the gaps, not the wavefront. Okay? Count the gaps, yeah? If the wavelength of the water wave is lambda, and that is what I have put over here, the wavelength is called lambda. What is the time taken for the disturbance at M to reach W? From M to W, how many gaps are there? Two gaps. So how many wavelengths? Two. From M to W, two gaps or two wavelengths. Right. So what's the distance of distance that the wave traveled? It traveled two wavelengths. They are asking for the time. So time is distance over speed, right? And they tell me the speed is v. So the distance is 2 lambda and over v. So answer will be D. Okay? And just as what I have suspected, they will have a 3 lambda there. Why? Because the student didn't count the number of gaps. They counted number of lines. Okay? So count the gaps, huh? Okay, so with this question is good that it will remind us to draw your normal. So those students who say, I need to go through, they need me to go through, is probably they didn't draw the normal. But once you draw the normal, you'll find that the answer is very obvious. I will not elaborate to save time. Can I go to the next question? No. Answer is C, they are not equal. By right, your incident ray or angle of incidence must be equal to angle of reflection. Okay? The student did not draw the image. The students did not draw the image. Now, I understand that the mirror is only this length. It is very short. But I need you all to extend the mirror using dotted line. Extend it using dotted line. Even though the mirror may not be of that length, I still need you all to extend. Because if I have a mirror that is this short, I can still see Clarissa. I can see Clarissa because the reflection from my handphone, although my handphone is this short, but because of the angle, I can see her. I can also see Sabrina. I can see Verlene. And I think if the thing is clear enough, the Verlene can see me. Because if I can see you, that means you can see me, right? Okay, so even though the mirror is that short, I need you all to extend. After extend, measure out equal distance with a perpendicular line to find your P, your image of P. But some of you will now say, but the mirror is not that long. Will there be an image there? Don't care. Just extend the mirror. Then, using the mirror that you have extended, locate the image of P. Locate the image of Q. Locate image of R. Basically, it will be all on this line. Now, you should be able to draw it very accurately using your ruler. For mine, you see that the gap is actually different. But this is just to show you a rough idea. What? Okay, so basically, if it touches the mirror, then it can be seen. So now I erase. I will be using my student Gauss method. So equal distance, instead of drawing all the images of all the other points, I draw the eye. I draw the eye. So this is E. Okay? So if this point cuts like that, that means it can be seen. How about P? Does it touch the mirror? It doesn't. So this answer. So actually his method is faster. Thin converging lens, it shows a path of two rays. Where is the image? Guys, where is the image? Left hand side or right hand side? Right hand side, huh? This one right hand side, huh? This one left hand side. Where is the image? Left hand side or right hand side? Right hand side. Right hand side, do the light rays meet? Do the light rays meet? If the light rays don't meet, they cannot form an image. Of course, if it's not right, then left. If it's not right, then wrong. So, guys, if the light rays, they don't meet, they cannot form an image. But, because this light ray enters our eyes, is being processed by our brain, our brain cannot accept that they don't meet, they will draw back all these light rays so that they meet, So now, the image is actually on the left hand side. Image is on left hand side. Okay? So what did I tell you? If the object is on the same side as image, the image will be upright virtual. If on the same side virtual, you need to memorize this. If object on left hand side, image on right hand side, image will definitely be real. So on this side, upright virtual. On this side will be inverted and real. Still remember my IR and UV. Then this is my L lens, right? Visible light. Alright. So we have infrared, visible light, then ultraviolet. Can? So in this case, is the object upright or inverted? Upright. You can see from here, they meet here, right? They meet here. So this light ray comes from the tip of the arrow. So it must form the image of the tip of the arrow. So imagine I look at your head, but inside my brain it forms your leg. Cannot be, right? It must be image of your head tally with the object's head. So as you can see, it is the same orientation. Same orientation means upright. Okay.
How do you know the image is on the left hand side?
Where do the light rays meet?
On the left.
So that is where the image will be. The images must have the light rays meeting.
Okay.
If not, they will just go on and they will never meet.
You never see it.
Yeah. But our brain, they receive the light ray, they will sort of form the image. Our brain is quite powerful. P is the object. How many light rays come out from this object? What you can see is 3. But actually in real life, how many light rays? Millions. There are some that comes out this way, there are some that comes out this way, there are some that comes out this way. 3 light rays that's drawn. Now we have 3 special light rays. 3 I will just draw on the side here. 3 special light rays. This is the object. Object usually on the left hand side. The light ray that passes through the center. How many light rays can pass through the center? Only one. Only one. Although the light ray comes out from the object, there are millions of them, but only one can pass through. So this one is a special one. Okay? So it passes through without bending. It don't bend. It's a straight line. It don't bend. So what is this thing called F? Very good. Focal point. Focal point, every lens have focal point. Different lens have different focal point. So the light ray comes out. There's one light ray that is parallel to the principal axis. How many light rays can be parallel to principal axis? Only one, right? For this case, only one. So this only one, it will touch the lens, then it will cut the focal point. It will cut the focal point. Parallel, touch the lens, cut focal point. Where are they meeting? You can see that they are meeting, right? So can we have an image form on the right hand side? Okay, if the image is formed on the right hand side, it is inverted and real. I show you that the arrow is the other way around, and it must be real because inverted real come together. Can you see the size, bigger or smaller? This one object, this one image. This one bigger, okay? What again? How to see the size? From here to here, you measure. From here to here, you measure. So we can see the size. But the inverted and real is based on where the image is located. And the inverted and real is one pair, IR. Okay? So this image is different from the UV that we did just now. Previous question. So far, okay? Okay. Then, besides these two special light rays, there's one more. So these three light rays will actually be the drawing that your seniors have to do for O level, but it's been taken out. But once it's taken out, I find it the 6 cases behind, you're like, what is this? Just like that memorize, man. But if you know how to draw, it will help a little. So if this is parallel and it cuts F, the third one that we have to know is cut F, then parallel. After it cuts F, that only one. Okay, guys. So now, if I have one light ray that goes this way, where will it end up? The blue light ray, where will it end up? Where? It will coincide with this image. It will coincide with the image. But how do we know that the image was there? By using the ray number 1, ray number 2, and ray number 3 to determine where the image is at first. Get it? So that was what your seniors had to do last year. I know. But then, when I teach them, they'll say, so difficult. Then they rather not know how to draw. It's always like that. Okay, but anyway, let's see how we can apply this. Is ray Z correct? Ray Z corresponds to ray 1, 2, 3 of my drawing. Which one? 1. Is ray X correct? Corresponds to who? Ray 2. What is ray 2 doing? Parallel to principal, then cuts F. How about ray Y? Is it correct? Why is ray Y wrong? It's supposed to go parallel. It's supposed to go parallel. So X and Z are correct. So are we okay? I think this one, if you are interested to know how to draw, to have an advantage over the other students, you can watch this video again. You are provided with an object and an image. Take your ruler, connect the tip of the object to the tip of the image. By the way, the image, is it, what's the characteristics? Smaller. Sometimes we use the word diminish for smaller. It is inverted. Inverted always comes with real. Inverted real. So this is corresponding to which light ray? Number 1, 2, or 3? 1, the one that passes through the optical center without bending. Therefore, C must be the lens. So now I need you all to practice drawing ray number 2. What is ray number 2? Parallel. After that, it should cut F, right? It should cut F, but it should also meet at the image, right? Wait, I think you all can draw it better. Okay, my PLD how to use ruler. So this is ray number 2. By the way, what is this point called? Focal point. This point is called focal point. Every lens will have 2 focal points, one on the left and one on the right. So if our drawing is correct, where is the other focal point? It's at B. Agree? Equal distance. Okay, I go back to here. This is where the light ray, after it goes parallel, it cuts F and touches the image, right? So the point where it cut is called a focal point. It's called a focal point. Every lens has 2 focal points, one on each side. Okay? So they must be equal distance, therefore this must be the other focal point. I'm telling you this. Can you now draw ray number 3? How do ray number 3 behave? Touch the focal point. Something like that, right? Can? So now, with this question, you learn how to draw what your seniors drew last year. Not all the time. Not all the time. Not all the time, the shape of this looks like a parallelogram. Not all the time. Okay, so there are a few concepts that you need to know for lens. Inverted rail, the size, optical center, principal axis, focal point, and if you can, know how to draw ray 1, 2, and 3. Okay?